Hello, ladies and gentlemen. Welcome back to my channel. This is Mr. Arias, and my channel is Math to the Point. In today's class, we're going to investigate the effect of A on the equation of any given quadratic function in vertex form. Just to review, the equation of a quadratic function in vertex form is the following. We have a function f of x, which is equal to A times x minus h to the power of 2 plus k. And please note that this value of A is multiplying the parenthesis which has the quadratic expression. So what's going to happen is we're going to have basically 4 cases as this value of A changes, and we're going to investigate each one of the cases one at a time. So let's begin. The first case is when the value of A is bigger than 0, which means that this value is positive. When this happens, what's going to happen is that the function, the graph of your function in this case, is going to be opening up. And if we look at the graphic calculator, this is an example of what happens if, for example, the value of A is 1 or 2 or 3 or 4 or 5, any number that happens to be positive. It could be a fraction, a decimal, an integer. That means that the function will be opening up in a U shape. Okay, so if you noticed, what happened here is that as we increase the value of A, this shape is kind of like closing down, but that's something we're going to investigate in the third and fourth case. So, but for now, just keep in mind that if the value of A is positive, which means it's bigger than 0, your function will be opening up in the following way. Now, let's investigate what happens if, by any chance, I turn that into a negative value of A. So whether this value is -1, -2, -3, -900, this function is now going to be opening down, which means that now we have this upside down U shape. This always happens in the second case, which is when the value of A is equal to, well, it's basically something less than 0, not equal. Could be -1, -2, -100, -500. It doesn't matter. Okay, we have case 1 and case 2, opening up and down. Now for the third case, if you notice, we have this absolute value symbol. So what the absolute value means is that this value of A could be either positive or negative. As long as this value, numerically speaking, is bigger than 1, what would happen is that the function is going to experience a stretch vertically, which means that the function will be kind of closing down and becoming thinner. So if I go back to the graphing calculator, this is something that we investigated a few seconds ago. So for example, if my function had a value of 2, and then I increase it to 3, 4, 5, or 900, what would happen is that this function is going to begin opening down like this and becoming thinner. I'm going to call this a stretch that happens vertically along the y-axis. So in other words, as you increase the numerical value of this A, this function will be resembling the shape of the y-axis. And check it out. This could even be negative. It doesn't matter. Whether the function is opening up or down, as long as the numerical value is bigger than 1, you are going to have this stretch. Okay? So let's put it back to normal so that you can see the normal case when A is equal to 1. Now the last case is the fourth case, which is this inequality that has 2 components, one on the left-hand side, one on the right-hand side. If the absolute value of A is bigger than 0, but less than 1, as long as I have any value between this range, what will happen to my function is that it'll experience a compression. It'll compress. And what that means is that it'll become wider in this case. Just to give an example, you can choose any number between 0 and 1, numerically speaking. I'll give you one quick example, 0.5, and I get this kind of like flatter shape of my function. If I decrease it, we get something like this. If I go even crazier than that, we get something like that. Let me just kind of quickly zoom it out. And you can see that this function is being kind of compressed, pushed down against the x-axis. Hence, the name or the phrase compression horizontally. So technically speaking, if I choose something even smaller than this, what would happen is that the shape of this quadratic function will be resembling the shape of the x-axis. And I'm going to call this a compression. Again, holds true if it's positive or negative. The only difference will be that the function will be either opening up or down. But again, the compression will be the same. It'll be respected. So this is the end of the video. I hope this helps, and I hope that you know how to tell the different changes that happen to the shape of this quadratic function whenever the value of a changes to any specific value. Have a wonderful day, and I'll talk to you next time, ladies and gentlemen. Bye-bye.